All right, welcome back, all you mathletes. We're back at it, and we're going to be talking about radians, arc lengths, and cofunctions today. The big things I want you to be able to do is convert between your angle measures between degrees and radians, find the arc length, and the cofunctions. I'm not that big of a fan on them, but I'll run through them because they may show up on a standardized test or something somewhere. Remember when we were doing degrees and sine of some degree and you'd get a weird answer, and I said make sure your calculator's mode is set to degrees, and you had two options there, degrees and radians. So today we're going to learn about what a radian is and how to convert between degrees and radians. So on your notes we're going to talk about radians first. To go all the way around a circle, you know that the revolution is 360 degrees. When you're talking circumference, if you remember circumference was 2 pi times radius. Radians kind of incorporate that radius idea, like the length around a circle, into an angle measure. So they say one revolution is 2 pi radians. Notice you have a degree mark and you have a radians mark. Sometimes they say radians, sometimes it's just RAD. If you go ahead and simplify with a unit conversion, you could say 360 degrees divided by 2 pi radians, as long as you put the units on it, you're good, equals 1. They're equal to each other. So it equals, and if we reduce that down, 2 goes into 360, 180. So 180 divided by pi, 180 degrees divided by pi radians is 1. Therefore, 180 degrees equals pi radians. If you keep that in mind, these conversions are very simple. You're either going to be multiplying by or dividing by 180 to find out what your angle is. So if you're trying to convert from degrees to radians, you should multiply by pi over 180. Yes, I know you got a degree mark up there. Just kind of mark that out on your paper. So you're going to multiply by this to convert degrees to radians. To go backwards, you're going to take 180 degrees divided by pi, and you're going to multiply by that to convert from radians to degrees. Something to note, 1 radian is not the same as pi radians. People miss that question all the time on the test. So let's do this first one. Convert 48 degrees to radians. So we're going from degrees to radians. So I'm going to take 48 and put it over 1. And then I'm going to multiply it by pi over 180. So all I do, the degrees cancel out, and I end up with 48 over 180 times pi radians. What you need to do next is put that fraction in simplest form. So if you simplify it, you end up with 4/15 pi radians. That's your answer, 4 over 15. Both of those can be divided by 12. There's a way to do it on your graphing calculator. I'll show you tomorrow. Convert pi over 10 radians to degrees. So convert pi over 10 radians to degrees. We're going radians to degrees, so I'm going to divide I'm going to multiply by 180 over pi. My shortcut is when I was in high school, I replaced the pi with 180. That's a shortcut, and because your pi's always cancel out here, the pi. You need to know this way in case they don't put it in terms of pi. So this is 180 over 10, which is just 18 degrees. Notice we could have just replaced the pi to start with 180. So if you have your radians in terms of pi and you're converting degrees, just replace that pi with 180. That's the shortcut I used. Convert 72 degrees to radians and convert 11 pi over 18 radians to degrees. What I'd like you to do is pause the video and see if you can do that on your own. 1 Mississippi, 2 Mississippi. Did you pause it yet? Did you? Did you pause it? Did you pause it? Okay, here's what you should end up with. Oops, back. You should have got 2/5 pi and 110 degrees. So for those two. If you had trouble with that, go back to the instructions and see what went amiss. Otherwise, ask me in class tomorrow and I'll work through it with you. Arc length. Now, when you were back in geometry, you may not have got to this, or you may have. When you were trying to find a length of an arc in a circle, it's part of the circumference. So what you would do back in geometry is you take the degree of the angle, this is a central angle here, and you divide by 360. That gives you the fraction of the circle. Then you'd multiply it times the circumference, which is 2 pi times your radius. Well, if you simplify, what you'll notice is that the 2 cancels with the 360. 2 goes into that 180 times. So you end up with this. Arc length equals your degrees times pi over 180 times r. Well, we just did this. Degrees times pi over 180, that's theta in radians. That's your angle in radians. So that's where this formula comes from. It's saying this arc length here, which is part of your circumference, is of a rotation is the ratio, let's see, the radian measure theta of a rotation is the ratio of the arc length s by a point at a distance r, that's your radius, from the center of rotation to the length of the radius. I don't really like this definition. If you understand this, that arc length equals theta times r, you're in good shape. So this theta in radians, they're trying to give you a better definition of what a radian is. Theta in radians is the arc length divided by the radius. So that's what it means. Radian theta equals the arc length divided by the radius. So to find arc length, here all you have to do is multiply your radius times theta in radians. So your arc length equals your radius times theta in radians, and this is where it came from. Clear as mud. I'll go through it again tomorrow if you're having trouble with it. So let's do this example. Find the arc length of a circle of 5 centimeters radius that's associated with a central angle of pi over 3 radians. So remember, the formula only has 3 things. S equals r times theta. S is the arc length, r is the radius, and theta is the angle measure in radians. So when I'm looking at this, the first thing I pick is this is the one I want because I'm looking for arc length S. I hate S. S is the worst variable ever invented. Anyhow, because it looks like a 5. So we know 5 centimeters radius, we're going to let r equal 5, and our central angle is pi over 3. It's in radians, so we don't need to do anything to it. So we just plug and chug. 5 times pi over 3 gives us 5 pi over 3 centimeters. The angle measures kind of hocusy-pocusy cancel out, so you just end up with a linear measure, centimeters. That's the length around. That's the length of an arc length. Measure of a rotation. In this case, when you see measure of a rotation, you're looking for an angle. So I like to draw this. The measure of the rotation is going to be this angle that's inside of here. P is the distance that the point P is moving along the circle, and they told you that the radius, or that there's a point 2 meters from the center of rotation. Here's the center of rotation. This is 2 centimeters. That's just your radius. But it's kind of like you need to decode it. So I would draw myself a circle, 0.2 meters from the center. A 0.2 meters from the center, that means radius. It travels 4 meters. So this is the point P. It's traveling along the edge of the circle 4 meters. So theta is what we're looking for. Our arc length equals 4 meters, so that's S. So we're going to have theta equals the arc length over r. Since we're looking for theta, we can go right to this formula. Theta equals S over r. So you're going to have theta equals 4 over 2, so it's 2 radians. Since we're looking for theta, our unit of measure is radians. All right, try these on your own, and I will check them in class tomorrow. See if you can figure them out, and I will see you then.